Hello, this is Scholar Strive with some math. Today in Algebra 1, we're going to be learning the quadratic formula. Last time we worked with the discriminant, and if you see the discriminant is right under here, under the square root. So the discriminant under the square root. And remember, the discriminant tells us how many solutions there are. Now, this formula will actually tell us the solution for any quadratic formula. And this is how it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So remember, this plus or minus, what it means is we have two equations going on. We have x equals negative b plus the square root of b squared minus 4ac all over 2a, or x equals negative b minus the square root of b squared minus 4ac all over 2a. It's whether you add the discriminant or subtract it. Or the square root of the discriminant. But let's do an example. So first, we need to find our a, b, and c value. So I need to move everything over to the one side. So I'm going to subtract 3x. So I have 2x squared minus 3x minus 5. So a equals 2, b equals negative 3, and c equals negative 5. And once again, we're going to use the formula x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to plug in our values. So negative b, or opposite of b, is positive 3 plus or minus the square root of b squared, so negative 3 squared minus 4 times a, which is 2, times c, which is negative 5, all over 2 times 2. So this will become x equals 3 plus or minus the square root of 9 plus 40 divided by 4. So this will change into two equations. This will be x equals 3 plus the square root of 49 over 4, or x equals 3 minus the square root of 49 over 4. Square root of 49 is 7. 3 plus 7 is 10 over 4, or 3 minus 7, which is negative 4 over 4, which is negative 1. So I have two answers, x equals 10 over 4, or x equals negative 1. Now, one way to remember this formula, how I learned it is, I don't know if you remember the song Pop Goes the Weasel, or I don't know, there was probably a original song before Pop Goes the Weasel, but here it goes. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me try that again. So quadratic formula goes like x equals negative b plus or minus square root of b squared minus 4ac all over 2a. It was funny because my teacher made us all sing this song about, I don't know, like 10 times. Mostly just because people didn't want to participate, but that is one way of remembering it. And this is a formula that you should remember, because if you go into Algebra 2, you're definitely going to use this. Oh, well, you're definitely going to have to remember this formula. It's a very good formula because it does help us with a lot of physics. Because a lot of projectiles in motion, whether it be a ball or a bullet or a rock, an apple, they follow a parabola. Which comes to example 2. A crabbing net is thrown from a bridge. So we're like, I don't know, how do I draw a bridge? Have some railing. And then there's water here, I guess. And then there's the guy throwing a net. Throwing a crabbing net. Oops. Well, anyways. So we have this formula that we saw a while ago, but let's remind ourselves. So our height after a time t is equal to negative 16 t squared plus v naught being our initial velocity, times t plus our initial height s. So let's write that all out again. H is the height after time. T is time. This v naught, or v sub 0, is initial velocity. So basically the speed at which the object was going. And s is the initial height. So, a crabbing net is thrown from the bridge, which is 35 feet above the water. If the net's initial velocity is 10 feet per second, how long will it take the net to hit the water? So they want to know how long it'll take it to hit the water. So we're going to say the height at the water's level is just 0. T is what we're looking for, so we're going to keep it as t. Our initial velocity, so the speed of the net, is 10 feet per second. So he threw it, and as it was leaving his hand, it was going 10 feet per second. And then it falls into the water. So S is the initial height. He was on a bridge 35 feet above the water. So now we're going to plug this into our equation here. 0 equals negative 16t squared plus v naught, which is 10, and then t plus our initial height, 35. Guess what? Quadratic equation. And it doesn't look like we can factor it easily. I mean, we could graph it, but we're going to use the quadratic formula. Okay, once again, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so plugging in our a, b, and c value, I'm going to get negative 10 plus or minus the square root of 10 squared minus 4 times negative 16 times negative 35. All over 2 times negative 16. I'm going to clean this up a bit. This is going to be negative 10 plus or minus, so 10 squared is 100. Although those three numbers, 4ac is 2,240. So I have the square root of 2,340 divided by negative 32. So I'm going to have two things. I'm going to have negative 10 plus square root of 2,340 divided by negative 32, or negative 10 minus square root of 2,340 divided by negative 32. And this is where our calculator comes in. So if we add, I believe we get negative 1.2. And if we, here, let me just put it here. Oops. Stop it. Why does it keep doing that? I just want my notes. Maybe if I close this, go back here. What is this? I want just to cancel. Okay, try it one more time. There we go. So if I do negative 10 plus the square root of 2,340 divided by negative 32, I will get t equals negative 1.2 seconds. And if I subtract, I will get t equals about 1.8 seconds. Now we have two solutions, but one of them is obviously incorrect. And that one, the one that's incorrect, is the negative 1.2, because it's not like, it's because he did not throw it 1.2 seconds ago. Can be going backwards in time because he was just holding on to the net at the time and then he tossed it. So we only have one answer, 1.8 seconds. So it takes 1.8 seconds for the net to fall to the ground. Or fall to the water. Okay, checkpoint 1. Use the quadratic formula to solve this equation. So first move everything over so it's equal to 0. Find your A value, your B value, and C value. And then plug it into the equation, negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 1 plus or minus the square root of 1 squared minus 4 times a times c all over 2 times a. So I'll get negative 1 plus or minus, if I clean up the inside, that becomes 25 all over 4. So I have negative 1 plus 5 over 4, or negative 1 minus 5 over 4. So I'm going to get x equals 1, or x equals negative 6 over 4. Alright, so we're still doing the same example for the throwing the net off the bridge, but they just changed a few things. So we want to know how long it still takes to hit the water. Our initial velocity now is 5, so I didn't throw it as hard or as fast. And for some reason, he's at a different bridge, which is 20 feet above the water. So once again, this is probably a formula to memorize or write down. H after time t is equal to negative 16t squared plus v naught t, v naught being the initial velocity, plus the initial height. So A equals negative 16, B equals 5, and C equals 20. if I rewrite the equation. Okay, we're going to plug this into the quadratic formula. -5 plus or minus the square root of 5 squared minus 4 times -16 times 20 all over 2 times -16. So this is going to split into two equations, -5 plus the square root of 1,305, or -5 minus the square root of 11305, all over -32. I'll get t equals -0.97 seconds, or t equals about 1.29 seconds. And we're going to choose the positive time because negative time doesn't work. Doesn't make sense. Example 3. Tell what method you would use to solve the quadratic equation and why. Now, if it can't be factored easily from the top of your head, it can't be solved easily just by moving things around, go ahead and use the quadratic formula. The quadratic formula is a good formula to just fall back on. You could say it's the lazy way, but, you know, seeing how much work we did, it's not the lazy way, but it could be the quickest way. Especially if we're having trouble trying to figure out the right factor, completing the square, or anything like that. Part B, this one is considered to be easily factorable. Again, if you're having trouble, use the quadratic formula. You can use it finding square roots. And I'll show you both methods. If we factor, we notice that both 4x squared and -36 have a factor of 4 that we can pull out. So it becomes x squared minus 9 equals 0. And this factors into x plus 3 times the quantity x minus 3. So x equals -3 or x equals 3. If we were using finding square roots, I would add 36 to both sides. Okay, and then I divide by 4. You get x squared equals 9. You take the square root of both sides, and you get x equals plus or minus 3. Same answer. Two different methods. But you can always fall back on the quadratic formula. So x squared plus 8x equals 9. So this, if you've been following, is in the form of completing the square. So we can use that method. Or we could factor it. Because if we move the 9 over, we have x squared plus 8x minus 9. Two numbers that multiply to -9 and add up to 8. That would be positive 9 and minus 1, which would give us x equals -9 or x equals 1. Now, once again, you can use the quadratic formula for any of these. -b plus or minus square root of b squared minus 4ac all over 2a. I'm putting a lot of emphasis on that formula because you either need to memorize it or write it down. Have a good day.